Good afternoon, class. How are you?
Sir, we're
Good
okay. How
afternoon,
are you?
sir.
Good afternoon.
Good
Hi.
afternoon, sir.
Good. Good afternoon, all. I am pretty well, and I'm very happy that you guys are sounding very chirpy. Um, we have a 3 hour marathon to go. Normally, normally I give students about a little 15 minutes, I know some of you would have had mm, um, chemistry 1 to 3, bio 3 to 5. So you just about a half an hour break. So I just want to wait a little, another 10 minutes here about so people can maybe get a cup of tea and just chillax a little bit. But in the chillaxing, I just want to have a conversation. Um, how was class on Monday? Anybody learn anything? Or was it you feel like you something that you can manage? I just need to get some feedback. Okay, so
Sir, it was
Sir, it
good.
was
It was
good.
manageable.
okay, because manager, all right, fine. Uh, is there any area of what it is that I did that is concerning, gave you some troubles, and you still don't digest it yet, or everything was good so far? Okay, JC, I'm seeing Javier, your response. All right, so tonight is a night where I am feeling very good. A little tired-ish. It's a Friday. You guys have to give me the energy. You guys have to come to class to talk. I don't want to be asking the question 2 and 3 times. I really want you guys to get into it, please. So when I ask the questions, I really, really, really would love if you guys would answer. Right, Kimoli. I remember. Yeah, by the way, anybody access the recording? Did you go silent again?
Yes, sir.
Oh, you were able, Shanti, to listen to the recording, right?
Yes, sir.
Yeah, man. So Kimoli, I'm gonna ask you, Shanti, to just recirculate the YouTube link again for me, please, so that those who weren't here can have access to it. And remember, guys, just subscribe. Thank you, Giovanni. Just subscribe so that when I make a post, you are notified. Let me just caution you on something here, though. So it's just one YouTube channel and a half. So when I post for my Calculus 1, you will also get that notification. But if you see that it says Calculus 1, you don't need to do it. But if it says K integrated math, of course, it is yours. Yeah, man. So I'm ready. I did ask in the group if anyone has past papers to share, and I got excited when I saw something came in. I mean, I'm very grateful for the full electronic version of the syllabus. Thanks again. Don't remember who sent it, but whoever did, much appreciated. But nobody has past papers. It's very good when we can work past papers, um, you know, in our sessions. No, anybody has past papers?
Sir, I have a site that I usually look on. I'm checking it now.
Great, thanks. Appreciate it. All right. In the meantime, I'm going to give you some questions just to play around with, because tonight we're going to be moving into logarithms, and logarithms is exciting. It's an exciting area. Let's see how far we can get into the logarithms. And okay. Yeah, I don't think I'll be able to finish all of this. It's quite a bit. And I want to make sure that I go through everything so that any question at all that plays on the paper, including logarithms and exponents, which is really indices. Remember, I did say to you that indices, another name for indices is exponents or powers. So when they say logarithms and exponents, it's really logarithm indices and logarithms that they're talking about, and one does not exist without the other. All right. So let me see if I can post. Let me see how can I get all these questions. Let me get these. All right, so I'm putting those questions on for you. I want to try it. Remember, no, when I say try, I don't necessarily mean that you must get it right. I just want you to put an effort. If you get it right, hooray. If you don't, at least when you're going through it, you can see where it is that you would have gone wrong. So start for me, please. Yeah, man. All right. So I'm seeing some messages in the group. I'm in the chat. People asking about the recording. The recording was sent. What I try to do is, as soon as the recording becomes available, it takes sometimes some minutes, sometimes depending on what time the class ends. I may fall asleep, but by the following morning, I'm going to put those to my YouTube channel. So please, those of you who have not yet seen it, there are others in the class who have seen it. I'm going to ask that you just go back to the YouTube channel and look for it. It is labeled Cape Integrated Math. It is labeled. So check again for me, even now, and let me know if you're seeing it. But I know it's there. For those of you who have just joined, there is work that is projected. I don't want you to sit and look at it. I want you to give it an attempt. This serves as a review of what it is that we did in class on Monday, and I'll go through the solutions with you just to make sure that you're fully following what is happening. To those of you who joined or are joining for the first time, it is important that you speak in class. Let me know what is happening. I'm not going to be tolerating a class online students who, when I ask questions, they are not responding to me. So please gather your thoughts because I need to have an interactive class. Don't put me to bed, please. It's a Friday evening. You want to be able to sit through the class. Oh, I just recognize number 1 and number 5. No, two different. All right, are we all finished with that one now?
No,
Yes, sir.
Are you doing it now? That's what you say, Shantae?
Sir, I'm finished.
Are you finished? Okay, but anybody else has completed the stuff?
Sir, just number 4 and 5.
You don't do 1 and 2 yet? And 3?
Yes, sir, I do them already.
You're just working on 4 and 5 now. All right, I give you another 5 minutes, guys. Who was my able assistant in trying to find the past papers? Did you find any?
no, sir, I didn't.
Oh no. All right, thank you,
This
Sydney.
site didn't have anything for integrated math.
Yeah, I have been searching. I came across just one diggy one. One diggy. But anyhow. That's what I got for my number 1. Is anybody in agreement with me?
Yes, sir.
Yes, sir.
Good,
Yes.
good. All
Sir,
right.
please repeat what the answer you got.
2 nines raised to the 5th power. Are you okay with that?
Sir, question.
Yes, good morning.
Sir, if you like raise this to the fifth power using like a calculator, would you factor it? Or
No.
you have to leave it like this?
Yeah, leave it as an index. The question was given to you as an index, so you're gonna leave it in the form that they gave you.
Sir, I wasn't here at the first class, so I was wondering if you could show the working out so I can understand how you got the answer, please.
Well, the working out is there. I mean, if you want me to explain it, sure.
Oh, yes.
Yeah, good. Can I be honest with you guys?
Yes, sir.
I don't think I'm the best person for this class. I hate coming to class and talking to students and I'm hearing myself. I know how my voice sounds. When I want to hear my voice, I speak to myself. I can't do this on a Monday night and a Friday night. No, I'm serious about it. I'm getting a little agitated because I know it's late night. But it's not late night, it's late evening. But the quicker we can get this out of the way is better for all of us. Let us go through the syllabus, finish the syllabus. We can spend time to go through the past papers. As I said before, I found one past paper and I'm going to give you questions from the past paper. But I can't do this by asking questions and people are muted and I can't. We're going through the participant list and calling Javier, John Mark, Kasana. I can't do that. I need to hear students speak to me. So this is the final time I'm going to speak to you about it because it's not good. And I just imagine what is happening in your bio classes, your environmental classes, your chemistry classes. You know, it is unacceptable. Unacceptable. All right, so let's go. So you're given 2 to the second power over 9 to the second power raised to the 5/2 power. Now we have a law of indices that says when I have a base raised to another power, raised to an index, which in turn is raised to another power, then you're going to be multiplying both indices. So a to the m raised to the nth power is going to be equal to a to the mn. When I have a base raised to a power, which in turn is raised to another power, I'm going to be multiplying the powers. I'm going to be multiplying the powers. All right? So this one is 2 to the second power, which in turn is raised to the 5/2 power. And 9 to the second power is also raised to the 9/2 power. So what I'm going to be doing is multiply this 2 by the 5/2. Now 2 is the same thing as 2 over 1. So I'm multiplying 2 over 1 multiplied by 5/2, and I'm going to get, when those cancel out, I'm going to get 1. See the cancellation here? When I cancel these 2's, I'm going to have 5 over 1, which is the same thing as 5. Similarly, this 2, so when I have this in parentheses, this 5/2 is governing both the numerator as well as the denominator. Not just the numerator, but both the numerator and the denominator. So it governs both. So I'm going to use the same 9 raised to the second power, in turn raised to the 5/2 power. I'm going to be multiplying the powers. So 5/2 times 2, 5/2 times 2, which is the same thing as 2 over 1. The 2's cancel, see it right here, so I'm going to be left with 5. So 9 is going to be raised to the 5th power. So what I have is 2 to the 5th divided by 9 to the 5th. 2 to the 5th divided by 9 to the 5th. And when I have 2 to the 5th, divided by 9 to the 5th is the same thing as writing 2 over 9 all raised to the 5th power.
No question, sir.
Mhm. Bless up, bless up. Thanks for that response. All right. See, just get a burst of energy a while ago. All right, so number 2, we got 125. 125 raised to the 2/3 power. Now, the aim is, the question was asked earlier, sir, what if I were to put my 2 raised to the 5th in my calculator and get an answer? 2 to the 5th power is 32. And what if I put 9 raised to the 5th power, which is plenty enough? No. The question was given to you in an index form. They expect you to write your answer in an index form. So whatever form that they give you a question is, that's the form you're supposed to give your answer in. Now, the form that this question is in is base and power. 125 is the base and 2/3 is the power. So I'm going to see if I can write my 125 into a base and power. And that would be 5/3. 5 to the 3rd power is the same thing as 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 is 125. And then the law that says, again, a to the m raised to the nth power is going to be equal to a to the mn. A to the m raised to the nth power is equal to a to the mn. So I'm going to be multiplying those powers. And when I multiply the powers, I'm going to get 5 squares. You notice I'm not even going to write 25. No, hear me out. So if this question came on the multiple choice, chances are you may not see 5 squares as the answer, because for what they may give you on the multiple choice is 25, right? So if you write 25, I'm not saying that you are wrong, but I'm saying to you, whatever form they give the answer in, unless otherwise stated, that's the form you're supposed to leave your results in. All right, supposed to leave your results in that form, the answer in that form. All right, so good. All right. Let me see. Hisana. Hisanya?
Yes, sir.
All right. Do you understand what is happening here with in number 2?
Yes, I'm understanding now, sir.
You're understanding now. All right, very good. Giovanni?
Yes, sir, I understand.
You understand. Very nice. Very nice. Very nice. Very nice. All right. Oh, and incidentally, again, what needs to happen is that you need to speak so that I can be able to differentiate the voices, eh? So that when they call me, I don't ask, who is this? Who is this? I can say, okay, yes, Kesana, yes, Giovanni, yes, you name it. All right, so 144 over 625. Again, what we're trying to do is to write our function in a base and a power. And you would know that 144 is the same thing as 12 squares. And you know that 25 squares is going to be 625. So when I use that, again, I'm going to have 12 squares for my 144, and 25 squares for my 625. So 12 squares for my 144, 25 squares gives me my 625. And then, again, the law that says a to the m raised to the nth power is equal to a to the mn. Once I have a base raised to a power, which in turn is raised to another power, I'm going to be multiplying the powers. So I'm going to be multiplying 2 by a quarter. Now 2 by a quarter is a half. So I'm going to get 12 to the half and 25 to the half. 12 to the half and 25 to the half. So this is what I have. 12 to the half here and 25 to the half. Right, so I have 25 to the half, sorry, 12 to the half divided by 25 to the half. But I can't convert this any further, the 12 that is. The most I can do with that question is write it as a third. Yeah, the most I can do with 12 is write as a third. I was going to ask the class if anybody could convert 12 into a third for you, but I'll choose not to ask the question. But 25 can be broken down because you know that 25 is the same thing as 5 squared.
Yes, sir. Can I turn it in a sir? You're right. 2√3.
2 root 3 will be correct. Very good. So it will be 2 root 3 if you write 12. So 12 would give you 2 root 3. But I have this 1/2 here that will change things around differently. Very nice. And 25, you know, 25 can be written as 5 squares. So again, I'm going to apply the law that this 25 I'm converting to 5 squares. The law says once it is that you have a base raised to a power, which in turn is raised to another power, I'm going to be multiplying the powers. And 2 times 1/2 is going to be equals to 1. So I'm going to have 5 down here. Let me ask a question. So we hear that 12 can be written as 2 root 3, which is a correct answer. How else, as an index, based on what it is that we did with indices or exponents, the syllabus called it exponents, but I'm calling it indices. Same difference. In indices is the same thing as exponents, the same thing as powers. So what it is that we're looking at now is indices and logarithms, but we call it logarithms and exponents. Much of the same thing. Tell me, based on what we did in class on Monday, how can I write now 12 raised to the half power?
So square root of 12.
Oh, fabulous. Excellent. Excellent. So I'm going to have it as a square root of 12. So it's going to be the root of 12 divided by 5. The root of 12 divided by 5. And that ends that question. The root of 12 divided by 5. Bueno. Very good.
Sir, what if you add 5 raised to the 4th power? Like before you do the 25 to the square, you just put 5 to the 4th power.
If I had 4 right here instead of 2?
No, sir, like at the 25 raised to the 25 squared. At the 25 squared. Go up one, sir. Go up one. Yeah, right there. In the bracket. You had 25 squared. If you had 5 raised to the 4th power. Right.
Very good. So that means you would skip this line, this part of the denominator. You skip this part of the denominator. You skip this part of the denominator and just jump to this part that says this one down here, 5. That is perfectly correct.
Sir,
Also,
that's what I did, but I got something else.
oh no, that means you never did it right. Tell me what it is that you did. Who is this?
Okay, so I had 12 raised to the power of 2, which would give you 144. But for the 625, I broke it down really small, so I had 5 raised to the power of 4. And then you would have the half. And then I set it up the same way like you do. You put the 2 over the 1 times the half, the 4 over the 1 times the half of the 5. But when I did that, I got 12 over 5 to the 2. And then I broke that down more. And I got 2 to the 3 over 5, all in brackets, and then index 2 outside.
2 to the 3 over 5. All right, go again. Walk me through what it is that you have.
Okay, so after I finish doing the rough work, doing the fraction and multiplying and canceling, I got 12 over 5 over 2. And then when I broke
hold on. Hold on, pumpkin.
Okay.
I'm actually writing.
Oh, okay.
12 over 5 over 2?
No, 5, index 2.
Oh, you said 5 over 2, you know.
Oh, sorry. 5 index 2.
Sir, can I ask you a question before you continue, please?
Sure.
Why you said the 12 couldn't break down anymore? I thought the bases were you just find half of the bases. Like, or you find 25 to 5.
You lost me. You said how it is that I said that I can't break down the 25 anymore, the 12 anymore? Right. Good. So this 12 here is I can't break it down anymore, right?
Yeah.
So were you able to break it down anymore? Any further?
Just wanted to add because all along I thought you just need to find half of the bases, like half, not really half, but something that can go in the 25 without leaving a remainder.
No. I have to fix that. I have to fix that misconception. Who is he speaking to me?
Me, Sir Gordon.
You were the one just a while ago talk about the base?
No, I said that I was telling you what I did and you were writing it on the screen.
No, man. Who was speaking after you?
That was Kesana.
Oh, that's Kestano. Okay, all right. Thanks, Kestano. All right. Don't lose me, Kestano, because I'm coming back to you with that one. It's fine because it's based on what it is that you're seeing. But what it is that you're seeing is a facade. It is not the right site that you are, focus is not correct right there. But I'm going to correct that. Because if you are able to say that to me, chances are I may have other students in the class who are looking at the, and I really hope that I'm understanding what it is that you're saying. But let me address Green's concern first, and then I'll come back to you. Okay, Green, go through.
Sir, it's Gordon.
Thank you, sweetheart. Gordon.
Okay, sir. So I had 12 over 5 index 2.
All right, hold on, because this is not writing at all. 12 over 5 raised to the second power.
Yes, sir. And then, sir, and then I had broke that down a little bit more, and I got 2 to the 3. I put that over 5, and then I would put the 2 on the outside of the bracket. Yes, sir. That's what I got.
All right, so let us just evaluate this and see if we get back the same thing as this. All right, because every step that we do is supposed to come back to the same thing. So this is supposed to be 2 to the third, all squares, and that's supposed to be 5 squares. Because when I have this 2 right here, it means that numerator and denominator are squares. All right, what we got back was a 5 squares for the denominator, so we know that, right? But for the numerator, we're going to have 3 times 2 is equals to 6. And 2 to the 6 is equals to 64. I think. What is 2 to the 6?
64, sir.
36.
Yeah, but this up here, Sister Gordon, is not 64.
Okay,
Yes.
sir. So where I went wrong.
Fair enough, but I'm not losing it yet. Because and this is why students, and this is why I really need for you to speak to me so that I can get into your headspace. And I'm happy that these questions are coming to the fore so that I'm afforded the opportunity to undo this misconception. It's very important. All right. So Gordon, so you recognize now that why I said to you that I can't break 12 down any further as an index. I can write it further as a third, but I can't write it further as an index. Can you see why now?
Yes, sir.
All right. Now, Cassandra, let me come back to you, hon. So you were saying that you thought that I'm finding a half of the number. That's what you're saying, right, Cassandra?
Well, not really the half, like finding the smallest number that can go into the number without leaving a remainder.
No. Okay, so let's just look at 25. I want to write 25 as an index. So I'm trying to find a number that when I write it as a base and a power. So this is going to be my base, and that's going to be my power. And another name for power is index or exponent, or yeah. All right. So then I'm looking at indices. So when I look at 25, I'm trying to write 25 as an index. It means now that I must write 25 with a base raised to a power. Now, what Gordon gave me a while ago, she was trying to write it as an index. But what she did was to say 2 to the third. But 2 to the third is not equal to 12. 2 to the third is equal to 8. And then 8 squares will be equal to 64. And that's what we got here, 64 right there. So it's not that we're trying to divide or to see which number can go into which number. We're doing a conversion. It's actually a conversion that we are doing to write it from a whole number to an index. And what do you mean by index, sir? It contains a base and a power. It contains a base and a power. All right? So 12, I can't write 12 as a base and a power because it just won't work. It just won't work. Look at what 25 is. When I write 25 as 5 squares, it is saying to me that it's 5 times 5 is 25. When I write 25, when I'm converting 125 as an index, I can say 5 to the third power. Why? Because 5 times 5 times 5 is equal to 125. So that's why I can write this here as 5 to the third power. Because I'm writing that number as many times as would give me that answer. So when I look at 49, it is 7 squares because I'm multiplying 7 by itself as many times as I possibly can in order to get back my whole number. So it's not that I'm multiplying 7 multiplied by 5 and raised to another power. No. Am I clear?
So, sir, you were
Yes,
trying to
sir.
write an index for to get back 12?
And I can't. That's what I'm saying to you. So I tried Kasana, but I couldn't. So that's why I had to leave it alone. So see it here, so when I wrote the 25, the 12 to the half, I had to write it back here. You know why? Because I can't break it up like I did the 25 into 5 squares. It can't be 6 squares because 6 squares is 36. It can't be 4 squares because 4 squares is 16. It can't be 3 squares because 3 squares is 9. So you see the point I'm making? Can't be 3 squares
Yes, sir.
because 3 squares is equal to 9. Can't be 4 squares because 4 squares equals 16. So 12 lies somewhere inside right here. So talk truth.
Yes, sir.
So it's going to be
Yes,
3 point something, don't it? It's going to be 3 point something square. Talk to me.
Yes, sir.
Yes, sir.
Right, because if this is 3 and this is 4, that means this is 3 point something squares will give me 12. You don't want to point something. We don't want to point something. We're dealing with whole number indices. Whole number indices, not fractional indices. All right, so Kasana, you see it now, honey?
Yes, sir.
All right, and guess what? If during the course of the class you're still not seeing something, don't hesitate to ask me because I want to make sure that I undo what it is that you're seeing. And if you see something and you're not sure about it, just verbalize it.
I
I'm
wanted
here.
to
Go ahead,
ask
honey.
about the square root at the bottom, or the 12 and the 5. Why you put it there?
All right, good question. Were you here last class?
Yes, sir.
Okay, no problem. Don't worry. I'm not even suggesting that you should have learned it from last class. Look at law 6 for me, Kisana. The n root of a. So you notice this m are the same m inside here, so this m is this m. So whenever we talk about the nth root of a, it's going to be equal to a to the 1 over m. So anything that is inside of the sleeve of the square root sign is going to be reciprocated and it becomes the index. See here? Whatever is in the sleeve of the square root sign will be reciprocated and become the index. All right. So Kesana, this is not for you. This is for the whole class. I have a vision. Last week I saw 23 of you. My vision is I know there's a new student who's told me that he's going to join for the first time today, but guess what? If it is okay, Dan, I hear you. Nice job. My vision is every one of you who do this exam will pass it. So I say this on the background that it's when I give you the handouts, I'm expecting that you guys read through the handouts. This is a good opportunity for me to stop and share something with you. Mrs. Williams and I were in a meeting yesterday in preparation for a meeting that I had today. And what I gather is quite a number of you are carrying 5 courses at Cape. Not all of you, but quite a number of you. For someone who went through the same process that you are going through now, I'm going to say to you that when Mr. Shan gives you the handout, and make sure that the handout is properly typed, sent off to you as a PDF file so nothing gets shifted so you don't know how to read it. I do a lot of narratives inside the handout, so it is that when you're reading it, it's supposed to be self-explanatory. You can't get these handouts and let them pile up on you, because carrying one CAPE subject is plenty, let alone the number of CAPE subjects that you guys are carrying. So I say this to say, those of you who got the handout, did no preparations for tonight's class, don't let it happen again. Trust me on that. Time wasted today will never, ever, ever be regained tomorrow. Trust me on that. Trust me on that. All right? Okay, so let's go. So whatever is in the sleeve of a square root sign is going to be raised, it's going to be reciprocated and becomes the index. The reciprocated becomes the index. So, Kasana, so good question. Love the question. You're actually thinking, and that's what Sir wants. Sir wants you to ask him the question. However stupid it may sound to you, you ask me. Make me tell you the question stupid, and guess what? You'll never hear that from me. All right, so you see, because this is 12 to the half, because this is 12 to the half power, what is going to happen is going to be the square root of 12. Sir, how you know that? Okay, thanks for asking. It's going to be the square root of 12 because whatever is in the denominator here is going to be in the sleeve of the square root sign right in here. So, but guess what? We never normally write it 2 because it's redundant. Just like we don't say that the rain is falling, or repeat it again, or reverse back. It's redundant. So we know that that 2 is supposed to be inside here if it is not. And that's why it's called a square root sign. All right? So because the 2 is supposed to be inside here, so what the point I'm making is, Kisano, is that anything raised to the half power can be written as a square root of that thing. Anything written to the half power can be written as a square root of that thing. So if you have a to the half, is the same thing as the square root of a. Q to the half is the same thing as the square root of q. 12 to the half is the same thing as the square root of 12. Got that, honey?
Yes, sir.
Very good. Are there any other questions though? I sense the questions coming. Any other questions?
Sir, what if I got a cube root 1? If it was cube?
Then it's raised to the 1 over 3. Then it is raised to 1 over 3. Anything at all that is in the sleeve of the square root sign is going to be reciprocated and it becomes a power. So if this were a to the 1 cube, 1 over 3, it would be the cube root of a. a to the 1 over 4, the fourth root of a to the 1 over 5, the fifth root of a. See number 5 here, number 7 here. Number 7 says the nth root of a to the m is going to be equal to a to the m over n. N is something inside right here, so when we reciprocated and become the index. See here, reciprocated and become the index to the 1/4. Then I'm going to multiply these two to get me m over n right here. Question. I sense there are other questions coming. No more questions? Everything's hunky-dory? All right, let's go on. Let's move, let's move, let's move. What did you get for the answer for 64 over 125 raised to the 1/3 power?
4/5.
4/5? Anybody else got 4/5?
Yes,
Yes,
sir.
sir.
Yes, sir.
Very good. Bueno. Is there anybody in the class that don't see how we get the 4/5 get?
So I don't see I get the 4.
No problem. Thanks, John. All right. All right. 64 over 125. I'm trying to write 64 as an index. Meaning say, I'm going to have a base and a power. A base and a power. But I know 64 can be written as 4 to the 3rd. Now, it doesn't always work. And I keep telling students it doesn't always work, but sometimes it comes back to bite me because students will say, but Mr. Shan says so. Look at what happens. You see this denominator here? Sometimes it is a hint what power these are going to be raised to. You notice I said the word sometimes. It doesn't always happen, only sometimes. So I'm going to be looking for something to raise to the 3rd power so that I can cancel out this. Yes, sir, I see it. Because 125, sir, is 5 cubed. See it right here, sir? And 64 is going to be 4 cubes. So I don't catch 64 to be 4 cubes. 6 times 6 is 36. And 36 times 4. Rubbishness. 4 times 4 is 16. And 16 times 4 is 64. All right? So I'm going to have this 64 as my 4 cubes. I'm going to have this 125 as my 5 cubes. And again, the law that says a to the m raised to the nth power is going to be equal to a to the mn. A to the m raised to the nth power is going to be equal to a to the mn. So I'm going to have 4 to the 3rd all raised to the 1/3. And this 3rd is going to be multiplied by 3. And 3/3 is going to give you a whole number. So this is going to end up being 4/5. This is very simple. And it's kind of straightforward because I don't have much calculation to do in that regard.
Yes, sir. I went wrong where you put the 4 to the cube. I put 8 squared. That's all.
No, man, and you're fine, you know. You're fine. Which one are you talking about? Number 4, right?
The same number for yes.
All right. Okay, no problem. So let me work with your 8 squares. Because we know that 64 is 8 squares, don't it?
Yes,
Yes,
sir.
sir.
Yes, sir.
What did you do, John Mark, with the 125? What did you write?
I put 5 cubes.
5 to the?
5 cubes.
Oh, 5 cubes. Sorry, I didn't hear you. 5 cubes. All right, no problem. And then all of this is going to be raised to the 1/3 power. So based on what Sir is saying to you, that this is going to become now 8 to the 2/3 over 5 to the 1st. That's what we got, John Mark? Sorry.
Yes, sir. That's where I
Okay. That's where I stop. But John Mark, look no, Papa. Remember, no, you know, 8 is a perfect something we can write as an index, you know, as 2 to the 3rd power. Talk truth. You see, John Mark? You see,
Yes,
no? Right. So I can now say 2 to the third power raised to the 2/3 power. I don't have to do anything else. And then this is going to be just over 5. This 3 cancels with that. So I'm going to have 2 to the second power over 5. And 2 to the second power is the same thing as 4/5. So whichever way you do it, John Mark, you should get the same answer.
Okay.
Come on. Any other questions? Any other observations?
No, sir.
No,
No,
sir.
sir.
Very nice. Love it, love it, love it. Thank you for the responses. I really appreciate it. It keeps me awake. All right. And the final, oopsie daisy, the final one. All right. That's what I get for my answer. Anybody got that?
Yes, sir.
Yes,
Very
sir.
nice.
Yes, sir.
Is there anyone in the class that is having a difficulty with that answer? All right, so I don't hear a response. I'm not going to look at it. All right. So now what I'm going to do is, and we're still recapping what we did on Friday, on on Monday. I'm going to look back at what we did on Monday, and I'm going to give you 2 diggy more questions. 2 diggy more questions, so I can move into my other areas that I want to move on in for tonight. Maybe towards the end of the class, I just be mischievous depending on how I feel, and just give you a little 1 question to work for me. All right. All right. I'm giving you 5 minutes to do 6 and 7 for me, please. 5 minutes to do 6 and 7 for me, please. Thank you. Have you completed the question?
Yes, sir.
Yes,
All right.
sir.
Very nice. What did you get for number 6?
Sir, I got 2 to the 8th power over 4 to the 3rd power. That's what I got.
Sir, I got 2 squared.
Okay. Whitfield, say it again. Very good. Oh Lord Jesus. I'm trying to learn the names and the voices.
Tatiana.
Tatiana. Okay, thank you, Sidi. I'm trying to learn the voices with the names, all right? Whitfield, say to me again what you got.
Sir, I got 2 to the 8th power over 4 to the 3rd power.
2 to the 8th power over 4 to the 3rd power. Hold on. Where's my pen? 2 to the 3rd power. 2 to the 3rd power over 4 to the.
Oh no, not 2 to the 3rd, 2 to the 8th power over 4 to the 3rd. That's what I got.
2 to the 8th power over 4 to the 3rd. All right. Now remember now, this 2 to the 3rd, that can be, well, not this one, but the 2 to the 4th can actually be broken down. So we can say 2 to the 8th power over 2 squares raised to the 3rd power, which would give us 2 to the 8th power over 2 to the 6th power. You see that?
Yes, sir.
Right. And the law says when I'm dividing and the bases are the same, I'm going to subtract the numerator power minus the denominator power. So this is going to be 2 to the 8 minus 6, which is equals to what? Tatiana, what you get?
2 squared.
2 squares. Tatiana, was that your answer, honey?
Yes, sir.
Yeah, man. So, Chanel, not bad, but your work is incomplete. Yeah, man. But not bad. And that's why I stopped, because when I worked it out into my head, I said, but okay, she's correct. So not bad, but I want you to complete the working out. It don't make sense you get the question for 5 marks and them only give 2 out of 5. When it is that if you just continue working it down, you can get the full 5. All right? Very good though. And then no, go ahead, please. Go ahead. Who is calling, sir?
Sir Leslie.
Yes,
Sir,
Leslie.
instead of 4 to the 3rd power, I had 2 to the 6th power.
2 to the 6th power, same difference. Because watch this, Johnny. Watch this, Johnny. 2 to the 6th. 4 is the same thing as 2/3. 2 to the 2nd power. And 2 times 3 is 6. Don't so you get 2 to the 6th power. So it's the same thing. It's the same thing. And see, I end up getting 2 to the 6th. Yes, honey?
What did you do with the 8?
I just let it stay there. I let the 8 stay there, and then when I get the 2 to the 6, I said 2 to the 8 minus 6, and I get 2 squares.
No, like the 8 times 32. So the 2 to the 8th power represent the 32, but what did you do to the other?
Cassandra, which 32 are you talking about, honey bunch? Oh, in the question.
Yes.
In the question. Okay. So okay. Sorry, I wasn't looking at the question. So tell me now, honey bunches. What are you talking about? What do I do with the 8?
Yes, sir.
All right, cool. You frightened me a while ago, you know, because I was just going to take away your dinner from you. I'll make you go to your bed hungry. All right. So look at what sir did. 8 is the same thing as 2 to the 3rd power. 8. This 8 is the same thing as 2 to the 3rd power. And this 32 is the same thing as 2 to the 5th power. And this 64 is the same as 2 to the 6th power. So let's go. 32 So what I'm saying to you is 2 times 2 times 2 is equals to 8, which is the same thing as 2 to the third power. So what I should do is put 8 equals, that's where we start. So 8 equals, so 8 equals 2 times 2 times 2, which is the same thing as 2 to the third. That's what I get right here. And 32, copy. And 32 is going to be equals to no, 1, 2, 3, 4, 5. 2 to the fifth power. Now, the question may be, sir, then all them did know say a 2 to the fifth and them knows a 2 to the third. So I mean, nobody know that, sir. Don't worry about it. You're now in the course. So the truth is, by the time we are to finish off our indices and exponents, we will know these basic ones. That 8 is the same thing as 2 to the third, 64 is the same thing as either 4 cubes or 2 to the sixth. All right, 125 is the same thing as 5 to the third power. 128 is the same thing as 2 to the seventh power, I believe it is. So you will know these as we get more mature into converting into an index form. All right. So now what I have done is to convert all this stuff into the same base. So now it is easier for me to apply the laws, because the law says when I'm multiplying and the bases are the same, I'm going to be adding my powers. So 2 to the third multiplied by 2 to the fifth, the bases are the same, 2 and 2. So it's going to be 2 to the 3 plus 5. Teacher, 2 to the 3 plus 5. And 2 to the 3 plus 5 is 2 to the 8. And 6 to 4 is the same thing as 2 times 2 times 2 times 2 times 2 times 2, 2 to the 6. All right? So that's why I have the 2 to the 6 here. So me now having 2 to the 8 divided by 2 to the 6, the law says when I'm dividing and the bases are the same, I'm going to be subtracting the numerator power from the denominator power. So it becomes 2 to the 8 minus 6 is equals 2 to the second power. Then, sir, what if I wrote 4? I would have gotten it right. And it depends. If you go into the multiple choice, you may not see 2 squares as your answer, but you will see 4. And if you're doing the essay paper and you have 2 squares and you put equals 4, and they see that you know that 2 squares equals 4, full marks. Full marks. Are there any other questions regarding this one?
Sir.
Yes.
Yes, sir.
Not
I'll come into you one at a time. Go ahead, please. Who is speaking?
Sir, me.
Yes, Cassandra.
So say if I have for the 64, if we did have the 4 to the third power instead of the 2 to the sixth power, would I get the same answer?
You won't, because you recognize that 4 now, 4 to the third, 4 can be written as 2 squares. Talk truth.
Yes, sir.
Yeah, man. So when you're doing your indices, it's always very important that you go down to its lowest term. Always break it down to its very lowest term. So that's the point I was trying to make, Susanna, that you may not have seen that 64 is the same thing as 2 to the 6th power. You may not see that immediately, but for sure what you can see is that 64 is, let me show you my point. So some of you may not see that 64, all right, some of you may only see this. Let me write in this other document since I don't want to mess up. New share. Some of you may only see this. Some of you may see 64. But 64, some of you may write it as 8 squares. But 8 is the same thing as 2 to the third raised to the second power. All right, I don't like how this piece here writing, so let me go to the other one. And then now that is going to work out to be 2 to the 6. Because this 3 times is still giving 2 to the 6. Somebody may say, sir, what I did was to say 64 is equals to 4 cubes. Not a problem. And I will say to you, how can I write 4? He says, sir, 4 can be written as 2 squares. And I would say, excellent. And I'd say 2 squares to the 3rd power. And then I say, what is 2 times 3? He says, sir, duh, no 6. And I get 2 to the 6. So you see, I get this to be the same thing as this. Anywhere I did, I'm going to get the same thing. So what the point I'm making, Kasana, is that the point I'm making is somebody may see 64 as 2 to the 6, the first go. Don't follow them, no watch them. In time, you will see that. You can only see it as 8 squares, or you can see it as 4 cubes. But if you break it down to its lowest term, step by step, I guarantee you'll get the full answer. Fair enough, fun?
Yes, sir.
All right, cool. There was another question that was coming though. Who was that?
John Mark here. So
Yes,
I was
John Mark.
asking that if it's only when you're multiplying and it have different base, you multiply the bases.
Very good, John Mark.
So if it's division, you don't
Good.
do anything to it.
No, sir. The division don't work. The division
No.
don't work. The only way the division works, John Mark, is this. New share. The only way the division works, Papa, is this. And I'm dividing, and the bases are the same. I subtract my power. Numerator power minus the denominator power. Numerator power minus the denominator power. Tell me that you see what I'm talking about, John Mark.
Yes, sir. Yes, I'm fine.
Any other question?
No, sir. That's all.
All right, thank you. Is there anyone else in the class that Natalia? I don't know why I keep looking at name and calling you Natalie.
understand.
You understand? Okay, so Natalia, tell me now. Unmute and say, sir, no, so I understand. Yeah, I want to know, man. Talk to me. Nathania,
Yes, sir.
how you stay? You're good? You're understanding?
Yes, sir.
Very nice. All right, Ricardo,
Yes, sir.
you good?
Yeah, man.
All right, very nice. Giovanni has been answering. Leslie answered me already. Fox, how you stay?
Yes, sir.
Good. Patrine.
Yes, sir. Good.
Nice. On green answer me. Tanisio, this is your first class, isn't it?
Yes, sir.
Hold on, please. So is your first class, Tanisio?
Yes, sir.
So, you know, unmute and tell me, good afternoon, sir. My name is Tanisio. I'm in
Oh.
charge here. $100 US.
$100? Oh
US.
my.
Yeah, and Tyree, this is your first class too.
No, sir.
You never seen a pause last time. You never named pause last week.
Yes, sir.
All right. Sharika, you were here last week, fun?
Yes, sir.
Why am I saying it last week? I mean Monday.
Yes, sir.
All right, good. All right, so I'm trying to learn the names, right? I know Mrs. Williams would have taught you guys, and she knows you all by name. So I'm only now trying to.
Sir, I can ask you something according to the
Sure.
Sir, in
$50.
multiplication, when you have different bases and you multiply the base, what do you do with the powers, sir?
The powers must be the same. In that case, John Mark, the powers must be the same. I'm trying to find it. See here, When the bases are different, the powers must be the same. Yeah, man. If the bases are different and the powers different, you can't use indices. If the bases are different, like in this case here, and the powers end up being different, you can't use indices.
But sir, what if the bases are different in division, right? And the powers are the same? Won't you arrive at the same answer?
No.
Sir, look what I have, like, when I multiply the 8 by 32, and I get 256, right?
Mm-hmm.
And then I put 16 squared,
Mm-hmm.
16 squared, and 8 squared. 16 squared over 8 squared. What I will do is divide.
No, hold on, Papa. Hold on. Because you can come up to the same thing that we're talking about here. So so you have so you have you said 8 times 32, 2, 8, 16, 3, 8, 24,
256.
256. And then you say, and what to do after that?
I have it 256 over 64, right? And then I put 16 squared, because 16 squared is 256 over 8 squared. What if I just divide the 16 by the 8, which will give me 2 squared, as the powers are already the same?
No, so
what will be the same answer?
So what needs to happen, John Mark, is to say 16 over 8 raised to the second power.
Yes, sir.
But it may work in this case when I said this into this goes that, and 2 times and we have 2 squares. But the law says BOMDAS or PEMDAS, brackets of multiplication, division before addition and subtraction, parentheses, exponent, multiplication, division, addition, subtraction. So brackets and parentheses mean the same thing. It may work in this case, but we have to check in other cases, would it work? Is what I'm saying? So once it is that is raised to a power, yeah, man. No, man. Once it is that is raised to a power, we have to deal with what is there first, right? So it works in this case. I would have to check in other cases to see if I don't want to tell it yes. I'd have to check the other cases to see if it does work in other instances.
All right.
For the division, but very good. This is the level of questioning that I want in the class. So it is that you have a notion, put it on the table, so it is that we can either agree or disagree. But very good thinking, though, John Mark. And I mean, if you continue like this, Papa, there is no way you can't get your distinction. Very good. And I'm happy for the others too. Yeah, man. I'm happy for the others too that have been, speaking up. I really appreciate your efforts. All right. So there is a third question, a final question. What was the answer for that one?
Sir, I got 1 to the 4th power.
Sir, I got 3 squared.
You got 3 squared. You got
Sir,
1 to
I
the
got
4th.
3.
Go ahead. You got what?
I got 3 raised to negative 3.
You got 3 raised to the negative 3. Okay. Anybody else?
So that is what I got. 3 raised to the negative 3.
Okay, very good. 3 raised to the negative 3. That one sounds like the correct answer to me. Let me go to my document. I was working a question with you. Let me go to my new share, go back to the document that I was working in, and go all the way down to here. And I should get my 1 over 3 to the 3rd power. Somehow I feel left right. 1 over 3 to the 3rd power. Yeah, there is 1 over 3 to the 3rd power. So look at that. Tell me if you agree with it, and then we can have a conversation as to why we got what it is that we got. And then to
Okay,
smooth.
sir, I understand
Okay.
the working out, but I did
Mhm.
something completely different.
Right. Okay. So this is Tanisha. What did you do,
Yes,
Tanisha?
sir.
What did you do?
So what I did was I got 9 to the 1/3 over 9 squared. And then
Hold on.
I did,
Hold on, pumpkin.
oh,
9
sorry,
to the 1/3.
9.
How did you get 9 to the 1/3 though?
So isn't that, oh, never mind. I see why I did it
Okay.
wrong.
Yeah.
Yeah,
Because 9 times a third.
I
Come
just
true.
realized.
Yeah,
I
man.
just realized.
So that's why I asked you. That's why I asked you to stop because I recognize it. Didn't recognize it.
Sir, because I wrote it down. I wrote it down wrong.
Yeah. All right. Very good. So I don't know if you guys, see how it is that I do my stuff. I am not one who is interested in answers. I am interested in the process. You see, once we can get the process going properly, the answer must come. If you follow the procedure and follow the procedure correctly to the T, your answer must come. You must get the answer. There is no two ways about it. It's a guarantee. So very good. So because of that
Sir.
error, go ahead, honey.
Sir, I expand the 9 and then
Very
use
good.
the
Very good.
the square part like the yes sir, but then I use the square part and just multiply it by the fraction. That makes sense. Sir, I
Lord
got for the
Jesus,
same thing where you got.
Jesus, forgive her. Miss Fox,
Yes, sir.
you'll have to get beaten.
No,
Right.
but sir, something like that, the sir. With the
Ome-
3 times the 1/3.
Amelia, but I'm going to put you and Miss Fox to the detention room. No.
Sir, so what I can do, done like
All right,
that.
I'm going to show you because let me tell you what I heard Chanel says. She said that she used this tool to multiply the third. That's what you said, right, Chanel?
Yes, sir. So that I have
Right.
3 and 2/3 in the next line of the working out.
And that is when you get an incorrect answer. So listen to what I want you all to do. Trust the process. Trust the process. And let me just stop and just motivate you here. As those of you are trying to catch up, I give you this is your opportunity for those of you who are looking at the question or maybe writing it down to catch up while I talk here. So, some of you will have friends who decide that them now go back to no more school after fifth form, they might go work because time hard. And they may say to you, say, why you go school for money? I work for me, I get $80,000 a month, and you sit down and say, no, $80,000, and you're working your own money. Geez, I mean, sometimes can't even find $80 to buy one little packet. Can't even $80. Buy one bag juice and one banana chips. But if you trust the process, you will make it. Because sometimes those persons who are going in there, they will find hard times, and they know they have to go and find other creative ways of trying to make it by going to scamming and going to this and going to that. You are trusting the process. So you have a goal ahead of you. Law, associate degree in CXC, nursing, medicine, engineering, turn one teacher. So you have your goals, trust the process. And I guarantee you, when you trust the process, there's nothing that can fail you once you trust the process. Because if you trust the process, you'll make it. Then, sir, what we have the 5 courses, don't worry about it. If you trust the process, you are going to study and be diligent so that when it's time for your exam, you will pass it because you trusted the process. Right? So I'm saying to you in the math here now, when I've said to you, Chanel, let me go here. When I say to you, honey, I recognize this 1/3 is the same thing I'm writing 3 to the negative 1. 1/3 is the same thing as writing 3 to the negative 1. So what I'm doing here is to say, that means that we can write 9 into a base 3 also, if that is the case. And I did, and I got 3 squares. Now the process says, when I'm multiplying and the bases are the same, I'm adding my powers. So it now becomes 2 plus negative 1, which is equal to positive 1, right here. So trust the process. See here, so recall, a to the m multiplied by a to the n is equal to a to the m plus n. When I'm multiplying and the bases are the same, I'm adding my powers. Every single time this works. And then my 8 to 1 is the same thing. Somebody will say, sir, I put 9 squared enough, sir. Not a problem. So having written the 9 squares, then you can say 3 squares, because you know that 9 is the same thing as 3 squares. So you're going to have 3 squares. So it becomes 3 to the 4th. See right here, so 3 to the 4th. 8 to 1 is equal to 3 to the 4th. So I'm going to put my 3 to the 4th here. And the law says when I'm dividing and the bases are the same, I'm going to be subtracting my powers. It's the numerator power minus the denominator power. So it's going to be 1 minus 4 to give me negative 3. Now, let me talk about this. Because somebody may say, sir, I left my answer 3 to the negative 3, and I see you put it as 1 over 3 to the positive 3. We are positive thinking people over this side of mathematics. Over this side of mathematics, we are positive thinking people. So we always write our answers as a positive index. We write our answers as positive indices. Eh? So that's why I wrote it as 1 over 3 cubes. Do you have any question?
No, sir.
All
No,
right.
sir.
Yes, please. All right. I think that was a no. All right. So now, having done that, this is a past paper, right? But it's not one of the, oh Lord, what time is it? 7:15. No, let me not do that. Let me not do that yet. Let me just go through some logarithms first. I can do that for homework. Let me go through logarithms first. All right. Do me a favor. Some of you might be lying down. Some of you might be sitting up. I'm going to ask you to just stretch it out a little. Stretch it out a little. I'm going to be starting something new. Stretch it out. Yawn it out. Stretch it out. Yawn it out. I want you to clear your minds. I'm starting a new topic, logarithms. And in looking at logarithms, even though it relates to our exponents that we just completed, if you understand this one, you have less things to catch up on. So I want you to just clear your mind. This is a new something. Yes, it relates to the one before, but you should be good to go. All right? Now.
So we can get 1 5-minute break.
Sure.
Right.
I have no problem with that. Go and go butter 2 slices of bread and come back. All right. So let us resume. Let us resume at I give you 7:25. I give you a 10 minutes break. One go walk, go bathroom and just cool off. 7:25. All right. Don't drop asleep, you know. Don't drop asleep. All right. I give you a 10 minutes break. Take your eyes from the computer and just take a screen break. Cool.
Okay, sir.
Okay, are we back?
Yes, sir.
Yes,
Oh,
sir.
nice. So, the sun ready. All right, so we have an hour left, and I really want to spend some time. And this is going to be the nature of what it is that I and how it is that I do the lessons. So I am presenting on logarithms now. So when I come to next class, all being well, I will spend some time doing some questions on logarithms and just clear up some of the stuff. So I really want to just present the material to you. We were one or two questions having presented the material, and then one of the things that I could do, I could choose to send you some questions via WhatsApp before, so we can practice those, or when we come to class, we'll spend some time, quality time, just sitting and just working on some questions. Very important. What is important is for us to work as many questions as we possibly can, so that we can become versatile in answering these questions. All right, John Mark, you back, Papa?
Yes, sir, I'm here.
Nice. Let's go. Let me bigify this one more time so that everybody can see what is happening. All right. So let's continue now. So we're talking about logarithms. Now, you notice strategically I start with unit 4. There are 8 units in module 1. Nice units to teach, as a matter of fact, in module 1. I started with module 4, and then I'm going to work my way down, and do a little something before I come through something guaranteed. Them something you're not bad. Them something you're doing is, for those of you who never did pure math, or the last time you did math was CXC, this is really not bad. I'm just going to ask you to just give me your undivided. Allow me to present it. If you see something that you don't know, jot it down, scribble it on paper while you're looking on the screen. So when I finish, you can say, sir, okay. So you said X, Y, Z, and then I'll be more than happy to take your questions. Logarithm. So a logarithm is a word for an index or a power. Logarithm is another word for an index or a power. Rockstone, then sir, that means a logarithm and indices really related, because indices come from the word index, and if one algorithm means something else, that means oh, okay, sir, something into something. All right, let's see if we can find out what is in that. For example, 2 to the 3rd power is equal to 8, and that is written in the index form. Sir, why? Because look at the left-hand side of that equation. The left-hand side says 2 raised to the 3rd power. I'm referring to a base and a power. So it's going to be an index. So that's what we mean when we say index form. That is written as an index form. So this is red. 3 is a power. Watch me. See it up yourself. 3 is a power to which base 2 must be raised to obtain 8. 3 is a power to which base 2 must be raised in order to get 8. Or I can say 3 is a logarithm, which with a base 2 gives me 8. Oh, so I see it now, sir. So that's why it's up here. So a logarithm is another word for an index or a power, because I can say 3 is a logarithm to which base 2 must be raised in order to give me 8. Got it, sir. Watch me. That is going to be written as in logarithmic form. 3 is equal to log to the base 2 of 8. You hear what his narrative said? 3 equals log to the base 2 of 8. So earlier on in the class, somebody was saying to me 5 5 and 3 or something of the sort. And I didn't stop the studio because I know I was going to come here. What is important is that you must have 5 raised to the third power or 5 cubes. Is it something like that? You have to be able to use the jargon in such a way that it encapsulates what it is that we are supposed to be speaking about. So 3 is equal to log to the base 2 of 8. 3 is equal to log to the base 2 of 8. I want you to take 2 minutes and look into that for me. 2 minutes, look into it. I am going to be asking you a question. And I will see those of you who are ready to watch Netflix after this class. All right, let's go now. So, here's my question. I want you to look at the index form up top. 2 to the third power equals 8. 2 raised to the third power equals 8. And I want you to look at the logarithmic form. 3 is equals to log to the base 2 of 8. 3 is equals to log to the base 2 of 8. 3 equals log to the base 2 of 8. 3 is equals to log to the base 2 of 8. 2 to the third is equals to 8. Look at those two equations for me and tell me, what do you recognize that is constant in both of them?
Log 2.
Log 2.
Base 2.
Say it again.
Log 2.
Log 2.
Base 2.
Base 2. The base 2. I don't want to say log 2, I want to say base 2. The base 2 is common to both. Sir, why not log 2? Okay. Listen to what I'm saying. 3 equals log to the base 2 of 8. Look at the index form. What is the 2 in the index form?
The base, sir.
Base 2. So what is constant in the pair of those things? The index form and the logarithmic form is that the base will never change. It's all about the base, about the base, about the base. The base will not change. 2 raised to the third power, base 2 raised to the third power. 2 is in the base position, raised to the third power equals 8. 3 is equals to log to the base 2 of 8. The 2 is in a constant position. The base, sorry. 2 is in the base. That don't change. If the nether 2 something, they might change. And you are going to help me to figure that one out. All right? Or if I want, I can flip it around and say log to the base 2 of 8 equals 3. Both of them are actually saying the same thing. All right? Any questions?
No, sir. No,
Okay.
sir.
No, sir.
All right, so watch me now. Watch me. I'm giving you those questions. 3 raised to the second power is equal to 9. And 5 raised to the second power equals 32. Remember, I said something earlier. Now you're hoping to listen to me and talking. I said to you earlier that 64, write it in a base form. You didn't know it because see them question here. No, me giving you 3 squares equal 9. So everybody gonna know what 3 squares equal 9 is. I could have given you 5 to the 30 equals 125, right? I could have given you 64 is equal to 2 to the 6. And I can go on and on. So by the time we finish this topic, we're going to be versatile on something here. But watch this. 3 to the second power equals 9. 5 squares is equal to 25. I want you to look at my logarithmic form. And I want you to take 2 minutes, 1 minute each, to write this 3 squares equals 9 into the logarithmic form, as well as writing the 5 squares equals 25 into the same logarithmic form. Write it in your books for me. You may know it already. Don't verbalize it yet. Write it in your books. 3 squares equal 9. Write in logarithmic form. Write it, write it, write it. And I'm going to call upon somebody. And when that person gives me the answer, you can let me know whether or not that person is correct.
Sir, for the first one,
Mm-hmm.
I have log to the base 3, 9 equals 2.
Okay. Is she correct? She said log to the base something equals 2. Is she correct?
No, wait,
Yes,
sir. So
sir.
wait.
Yes,
Log
sir.
to the base 3, 9 equals 2.
Them tell
Sir,
you yes
doesn't
already. Them tell you yes already and still go by something.
cause I said it wrong.
Okay, you said it wrong. All right. Let me check. Let me check the view. Let me check it here. Oh no, sorry. No, I'm here. No. I'm giving the answer for that one. I don't want to show you the answer for that one. All right. So say it again. No, you're saying it is going to be what?
Sir, log to the base 3, 9 equals 2.
Log to the base 3 of 9 equals 2. Okay, good. All right, very good. Proud of you. You are learning. Excellent. Now, you know who I want to answer me now? Mr. Powers. So we are talking about you the whole time, you know, index and powers and exponents. And you're not answering me.
Yes, sir.
Yeah, man, your turn. Now your topic is in a papa.
Makes sense, sir.
Yeah, man, 5 squared equals 25. Write it into the logarithmic form for me, please, and tell me what you get. Anybody did it already? What's the answer?
Oh. 25 equal to right.
Tariq, say it again, Papa.
Log of 20 equal to
You break up a while ago. Say it again. Log, I just hear log.
log to the base 5 of 25 equal to.
Very good. Excellent. 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 Is there anybody in the class that didn't get any of the two right? All right. Sounds like you all did. Very good. Now, I am throwing that question out. 1/5 raised to the negative second power is equal to 25. 1/5 raised to the negative second power equals 25. I want you to write that from the index form to the logarithmic form for me. And I'm giving you a minute, and I'm going to call upon somebody to tell me this one. Okay. Somebody tell me. Hold on, not somebody. Natalia. Natalia, how did you write that 1/5 raised to the negative second power equals to 25 in the logarithmic form? Not hearing you speaking.
No.
You don't know? All right, no problem. That's fine. And I like your honesty. And that's why I want you to speak more to me in class. Heinz.
Okay, log to the base 5 of 25 equals negative 2.
Log to the base 5 of 25 equals negative 2.
Yeah.
Is she correct? Don't tell me the answer now. I'm just asking you. She said log to the base 5 of 25 equals negative 2. Is she correct? Yes or no?
No, sir.
Okay, stop.
No,
Good.
sir.
Okay, fine. No. All right. Come, Heinz. So just say no. So look at it again and tell me what the answer is supposed to be, Heinz.
Only two answer right. So
All right, tell me the other answer now then.
log to the base 1/5 over 25 equals negative 2.
Is she correct?
Yes, sir.
So I never hear.
She said she now said log to the base 1/5 of 25 equals negative 2.
Yes, sir.
All right. So you're no correct, Heinz. So why do you have to give me the wrong answer first?
Yeah, I think we have person number.
Yeah. All right. So look at this one. Oh goodness, who did I call again? Natalia, I want you to look at this. Look at me, honey, bunches, please. Don't lose me. Don't lose me, Natalia. So remember, that's why I asked the question, what is constant in all that we are doing? What is constant in all that we are doing? What is constant?
Can I say something?
Guess what? You are very low, and I'm not wearing my glasses, so I can't hear you so well.
You hear me better now? I was saying, can I say something?
Sure.
For the 1/5, I put it 5, -1, then the bracket, then the -2, and then I did the fraction thingy, and then it would leave 5, -2. So that's why I got the second one that I got.
Yeah, see that? But remember, the point I'm trying to make is, remember I said to you that what is constant was the base, because the base in both forms, the logarithmic form and the index form, are the same. The base never changes. The base never changes. So when they're converting from the logarithmic form to the index form, you know why I'm emphasizing this? Very important. Very, very, very important. As I told you, I was only able to find one past paper, and the lone past paper I got, I started working, the solution to the question, the topic that I've already done, and I'm not going to have the time to just go and sit down and work the whole paper. So I have to work the paper as we go along. So by the time we finish the course, I should finish a set of past papers. All right. So the one that I have, there were 2 questions on the past paper for 4 marks each. And I did those. And I want to give them to you in class because I want you to recognize that the importance of in getting an A is, or the secret in getting an A is really to work in your past papers. So I want you to get your past papers and you can share them so I can have them and we'll go through them in class. Very, very important. All right, watch me. Remember that the base is always in the base position for both the logarithmic form and the index form. In both the logarithmic form and the index form. Now, I said something to you. And what is very excellent is that with what I said to you, many of you were able to use that explanation to write the other stuff. I don't even give you the law yet, but you were able to apply the law. Very good. Very, very, very good. I'm very proud of you. For those of you who are seeing this stuff, those of you who are not seeing it just yet, remember we have a little bit more work to do. Don't lose me, still focus. Still focus and still try to get it, okay? Let's go. So I'm saying to you that it can be written, in the form -2 is equal to log to the base 1/5 of 25, or log to the base of 125 is equal to 2. Whichever one you want to write it. Whichever convention would be correct. Whichever convention would be correct. All right? Now, in words, -2 is a logarithm, which a base 1/5 gives 25. So we have seen that the base of a logarithm may be any number. Common logarithms have a base of 10. Common logarithms have a base of 10. Take out your calculator for me, please. We can play a game. I want you to use your calculator and find log of 8 for me. I want you to use your calculator to find log of 8 for me.
Found it, sir.
What is that?
0.9030899987.
Very nice.
Yes, sir, I got, sir.
Very nice.
Yes, sir.
You were quick on your fingers. Very good. Is there anybody in the class that don't get that yet? I want you to be honest and tell me, because there's a reason I asked you to grab your calculators. Matter of fact, when you come to your CAPE class, you need to have your calculators, because trust me, I need to take a deliberate effort to show you how to use your calculators. All right. So we got 0.903089987, similar to what I have on the screen right here. Do me a favor now. Don't clear your calculators. For those of you who give me the answer, I don't want you to clear your calculators. Don't clear it at all. This is what I want you to do for me, because you have to press the equal sign just once. So this is what I want you to do for me now. I want you to press 10. Press 10. Don't press anything else, just press 10. And then some of your calculators will have an upside down V. Some of your calculators will have X to the Y. Some of your calculators will have Y to the X. Whichever you're seeing, the upside down V beside the X squared button, the X to the Y or the Y to the X, I want you to press it one time for me. I'm going to press it one time. I want you to look at the base of your calculator. And I want you to press ANS. So when you press ANS, it means that the answer that you got from before is now going to go up into the parentheses, and then press equal and multiply.
8.
Magic. Magic. Yeah, man.
Yes, sir.
Yeah. Oh, we so bright.
Sir, go again. Minus a
Min-
syntax error.
What calculator are you using?
The Texas Instruments.
Okay,
Did I
Texas.
say-
Yeah, I really don't like Texas Instruments, but never mind, it can work. So let's go again. Let's go again. The algorithm that I'm giving you, you must know how to perform these algorithms on your calculators. All right, so the first thing I asked you to do was to find log of 8. Some of your calculators, you may have to press log first and then 8 after, or sometimes you may have to press 8 first and then log after. Some of your calculators, if you press log and then 8, it just says syntax error. But if you press 8 and then log, it gives you the answer. So you have to know how your calculator works, which brings me to another point. Never, ever, ever go into an exam and just borrow your friend's calculator for your 1 hour. For your friend's calculator, you don't know how to use it. But you can shut your eye and use your calculator. So never, ever, ever, ever go and borrow a friend's calculator while you're walking into the exam room. Problem. All right, so let's go.
Sir, okay. So I finally found the symbol you told me to look for. So what do I do after that?
You're gonna find log 8 and you get 0.9 rate 8.
Yes, sir,
And
I
then-
did that. I was just looking for the symbol.
Okay, fine. Then you're gonna press 10. Press 10. You're gonna press the upside down V,
Yes,
the X,
sir.
X to the Y or the Y to the X. Then you're gonna press ANS, answer, and then press equal.
Yes, sir, it worked. Thanks. Sir, I
Magic.
got 8, yes.
Magic. Is there anybody in the class that still don't is there anybody in the class that is not where I'm at? I would have left you in indices.
Sir, it's still not working.
All right. What can oh yeah, and is it
talking.
and is that I'll come into you. Is that text you're the one with the Texas instrument?
Yes, sir.
All right, let me see if I can remember how I used to use my Texas. You're supposed to be seen to the far left hand side, X to the Y. I don't even know which brand Texas instrument you have.
That was an X to the Y.
Give me a flavor.
That's the upside down V.
Oh, you see the upside down V? All
Yes,
right.
sir.
Oh, that means you have the cheaper version of the Texas then. Don't follow me. Let's go. So you find log 8 for me?
Yes, sir.
Nice. So do me a favor now. Press 10. No, hold on. Clear the calculator. Clear the calculator for me, please. And then find log of 8 for me again now. Until we get the 0.903 rate 80.
Yes, sir.
Good job. Don't press nothing else. Now you're going to settle down and press 10. Press 10. Then you're going to press the upside down V. When you press the upside
Yes,
down
sir.
V, you're going to press ANS. So sometimes the ANS, the answer recall, is on the top of the key. If it's on the top of the key, it's no problem. But if it is
Oh,
so
sir,
cut,
I see.
you get it now?
Yes, sir.
Good. So when I ask to press ANS, sometimes your keys may be on the top of the key itself, or sometimes it is submerged. In order for you to access those, you have to press the second shift button in order to capture those, right? But your calculators you must play around with the calculators in order to know how to use your calculators. Very important. All right. So what it is that you don't know is that your calculators can only evaluate in log to the base 10. Your calculators can only evaluate in log to the base 10. So this is the exercise we just did. Or we can also write it as log to the base 10 of 8 is equal to all of that. So you look at it here. This is a point I'm trying to develop. You notice I'm saying to you, 10 to that number is equals to 8. I'm actually proving it to you. 10 to that number, when we convert this from the logarithmic form, when we write this into the logarithmic form, we're going to get log to the base 10 of 8 equals all of that. See here? Log to the base 10 of 8 equals all of that. A common notation is log 8 is equals to that, which is what you would have done here. So important to note that whenever you're not seeing a base, assume base 10. Whenever you're not seeing a base written, assume base 10. Right? So you recognize that your calculators just know that you calculated the stuff. You are actually calculating in base 10. Your calculators are calibrated to calculate in base 10. Now, there are some very good calculators on the market. And I'm going to tell you my preference. I am biased when it comes on to Casio. So I have a Texas Instrument from when I was studying on campus that I kind of don't want to separate myself, from it. But you have to know how to manipulate your calculators. Very, 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 very important. If you don't manipulate your calculators well, you're going to be in problems, serious problems. So important to note that when you're not seeing a base, you're going to assume base 10. So if I say log 6, what it is that you're doing is log to the base 10 of 6. Log 20, it is log to the base 20, log to the base 10 of 20. 100, log to the base 10 of 100, right? So when you're not seeing a base being specific, you're going to assume base 10. Now, if I say to you, log to the base 2 of 5, you can't change the base 2 to the 5 alone, right? You have to get in touch with the head of, whatever it is. So what it is that I really want you to do for me is look at this example. Log 10 of 100 is equals to 2. Implies that log 100 equals 2. The point I'm making is when you're not seeing a base, you're going to assume base 10. But if it is the base is given, you can't change it, right? And this course asks us not to teach you how to change base. So the changing of base is not a part of this course. It's a part of Unit 1 math or Unit 2, one of the two, right? But when you're not seeing a base, you're going to assume base 10. So if I say to you, log 100 is equal to 2, best believe that it's log to the base 10 of 100 is equal to 2. All right? Now, so look at what I'm doing. I'm converting this from the logarithmic form, and I can use this one here. Converting this from the logarithmic form to the index form. So it's going to be 10 squares equals 100. We know this. We know this. We have been doing this. So it's 10 squares is equal to 100. So this is so because a to the c equals b, where a is 10, b is 100, and c is 2, right? So I'm just talking about the position of these things here. Look at the law. That's the law that we have been working with without Mr. Shan giving you those laws. Log to the base a of b equals c is going to be equals to b equals a to the c. Or a to the c equals b, I'm just flipping it around. A to the c equals b is equals to log to the base a of b equals c. So converting from the index form to the logarithmic form. Converting from the index form to the logarithmic form. Converting from the index to the logarithmic. So how you know the difference between index and logarithmic? The logarithmic form have log in it, and the index form does have base and power. All right? So that's the formula we're going to be using to interchange between the logarithmic form and the index form. I'm going to pause. Pausing. Are you okay so far?
Yes,
So
sir.
can I repeat what you just said all of it, please?
Okay, sure. I'm happy that you're following. Repeat what I just said. I'm saying to you that we are now looking at the law. The law says log to the base a of b equals c is the same thing as a raised to the c power equals b. Log to the base a of b equals c is the same thing as a raised to the c power equals b. These two are saying the same thing, just that I flipped it based on some students' preference, right? So that's what we use to convert from the logarithmic form to the index form, and vice versa. So I should be able to convert from the logarithmic form to the index form pretty easily. Let me see if you can do that for me pretty easily. There you go. We have less than half an hour, and I have 10 questions to give you that can be done in 10 minutes, really. All right. So I want you to write it. So I want you to do the following. Express the following logarithmic form for me. I'm going to give you 5 minutes, a minute per question. I'm giving you 5 minutes. Start now for me, please. All right, finish that one now. Those?
Yes, sir.
Yes, sir.
Nice, nice. All right. So as to give those persons who are not talking to me an opportunity to unmute. Nathalie, what do you get for the first one?
Yes, sir.
What do you get for the first one?
Sir, I got log no, log 5 log base 5 of 125 equals 3.
Is she correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Very good, Natty Dread. Very nice. What more want you talk to me more in class here, Mom?
Sir, I always attack you, just not hear me.
All right then. Because you know who is the next victim? Sharika. Sharika, I want you to answer teacher in this now. What you got for number 2?
Log to the base 7 of 49 equals 2.
Log to the base 7 of 49 equals 2. Is she correct?
Yes, sir.
Nice.
Yes, sir.
Very nice. Amelia, what says you? Number 3.
Sir, log base 121 1331 equal 2/3.
Is she correct?
Oh, sorry, not 2/3, sir. 3
No,
over 2.
sir.
Oh,
Sir,
okay.
not 2/3.
Not 2/3.
Yes,
What?
sir, mistake. 3 over 2.
I'm going to charge you. I'm charging you. Yes, 3 over 2 is correct. Very nice. 3 over 2 is correct. Very nice. Now, who is next? Patrine, it's your turn. Number 4.
Sir, log, sorry. Log to the base 9 of 1 over 27 equals negative 3 over 2.
Is she correct?
Yes,
Yes,
sir.
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 Very good. Okay. Natalia, I want to make sure that you're following me with this one. Try number 5 for me, Natalia, and tell me what you get for the answer.
I put 1 as the answer because
Not explain to me. Just tell me what to write as an answer in the logarithm form. Maybe we'll talk about that afterwards. Tell me how you get it. Tell me how you wrote it in the logarithmic form.
I didn't remember writing anything. I just put 1.
Not Miss. Yeah, follow to me. No. You saw how the others did 1 to 4. Were you listening?
Yes, sir. That's what I have for 1 to 4.
No, I don't understand what you're saying. All right. Who wants to take number 5?
Sir, I have a question.
Go ahead.
Sir, for number 4, can you have log to the base 9 of 27 to the negative 1? Or does that be
you can have 27 to the negative 1, yes. You
Okay.
can have 27 to the negative 1, but guess what? We're using what it is that they gave you.
Okay.
But yes, if you have 27 to the negative 1, you are perfectly correct.
All right, sir.
Yeah, cool. Who wants to take number 5? Anybody?
Sir, I'll take it. Oh,
Go
never
ahead.
mind then.
Whoever first. Come quick. Whoever first unmutes, take it.
Log to the base A of 1 equals 0.
All right, good. Excellent. Very good. Natalia, you hear what Tantan says? Log to the base A of 1 equals 0. So what she did was to look at the logarithmic form. So remember, sir said to you, the base is always the base. The base is A, C is the power. log to the base A. The base doesn't change. It's all about the base, about the base, about the base don't change. Base A, base A. The only thing that changes the other two, something them. So watch me now. If I give you A to the C equals B, it's going to be log to the base A of the 1 year equals the 1 year. So log to the base A of B are going to equal to C. So I will say log to the base A of C because we have to call this first, then go over to here so, and then come back to over here so. All right. So watch me again. A to the C equals B is going to be log to the base A of the 1 year equal the 1 year. So we'll go from Yasso to Yasso and back up to Yasso. You see, Natalia?
Yes, sir.
All right, very good. So those are they. Excellent. And I'm ending class asking you to do that one for me. That's the last example we're going to do in class today. I'm giving you another 5 minutes. If you finish those, we can finish 10 minutes earlier tonight. So work on it, 5 minutes time, and then I'll explain afterwards.
What should we do, sir? Exercise 1.2b.
Yes, please.
Sir,
Yes, hon.
you want us to do exercise 1.2b, right?
Exercise 1.2b, that's what I want you to do for me now. So start for me, please.
Sir, excuse me, is that how number 4 and 5 supposed to look?
Yep.
What number 4 and 5? Oh yeah. Yeah, number 4 and 5.
Yeah.
Good, yeah. Everybody finish?
Yes,
Yes,
sir.
sir. Yes, sir.
All right. So let us see if we can just do this, and then we wrap up, and then we have a good weekend, and then come Monday again we meet. So we start the week and we end in the week. So we're converting this now from the logarithmic form to the index form. Kisana, what is the first one?
Me, sir?
Yeah.
5 to the 4th power equals 625.
Is she correct?
Yes, sir.
Yes, sir.
Yes, sir.
Shantae, number 2.
A half raised to the negative 2 equals 4.
Very good. Danique, number 3.
X raised to the power 2 equals y.
Excuse you? That look like 2 to you, Dan? And I'm just troubling you.
Yes, sir.
It's actually a Z, but never mind. I'll accept it as the answer.
What you say?
Yeah?
Oh, yes, sir, a Z.
A 2, she said.
Sir, a Z, sir, my glasses.
Yeah, never mind. But you're correct, though. And then, no, who should I trouble with? Janae. Sir, when
No,
number
sir.
4. John, number 4 are yearns. Come, Miss Les, come, number 4, come, work with teacher.
Sir,
I love you too.
let me just tell you what I have on this book. I don't know if it's right. So I have 1,000 equals 3 to the 0. That's what I have.
Okay, all right. Is she correct?
No, sir.
No, sir.
Can you help her out? Help her out for me.
Is
Sir, 10 to the 3rd
equal 1,000.
10 to the 3rd equals 1,000, right? John.
N?
10.
10.
10. I understand.
When you do
Because
base,
when you do have a base here, you assume it is 10.
Oh.
No, nice. We can't hear.
No, but okay, let me tell you what they said. They say when you're not seeing a base, you're going to assume base 10. So this is a 10 down here. Then, sir, or the O Mason, don't worry about it. This is just another convention of writing log. Then you can write it as LOG or then you can write it as LG. So when you're not seeing a base, you're going to assume 10. So this is 10 to the 3rd equals 1,000.
I thought it was a 1.
Which one? Where's the one? No, 10, man. Remember, sir, say up here, so important to note, any base other than 10 must be clearly written or stated. So if you're not seeing a base, down there, you can assume safely that it's going to be base 10 every time. All right? But it's Winwood. I mean, you guys, if you ask me, this is excellent work. And then no, anybody take the last one? What's the last one?
10 raised to the 0 equals 1.
10 raised to the power 0 equals 1. So number 5 is exactly the same thing as number 5 here. All right? And those are there for your answer. Oopsie daisy. Those are there for your answer. And then come Monday, no, all being well, we're going to move into some other little stuff because you see them something here now. We're going to move into some equations. And after we move into equations, we're going to move into some calculations there. And then what I want you to do is to work on your factorization. We're going to look at some big laws and then factorization. Those are big laws. Then factorization, something here we're going to work on. So I thank you for coming out. Anybody learn anything today?
Sir, I'm not going to lie.
Yes, sir.
At the logarithm, at first, I get something right.
Guess what, Kasana? I am proud of you. Don't worry about it. So if sir come to class and sir rough you up and say, Kasana, you need to understand this stuff, it don't mean that sir don't love you, no. It means that sir is trying to push you to get the best out of you. And what it is that you did tonight, I am proud of you. What you now need to do, Kasana, is to look over, maybe not tonight because it's kind of minutes to 9 o'clock or almost 8:30. So what you need to do is just maybe go relax yourself. And even though tomorrow is Saturday, get up and try and reinforce what was done. As soon as I get the recording, I'm going to send off so you guys can listen to the recording again. For me, you guys did very well. I thank you for responding to me when I asked that you speak to me in class. I want to hear you speak to me. Speak to me. Let me tell you, say, okay, I don't want to hear from you. And trust me, sir, I'm not going to tell you that. I want to hear from you so that I can know exactly what is going on into your headspace. I was able to correct either 2 or 3 misconceptions tonight. And this is what is important in the matter. I don't want anybody to see something and just have, oh, that sir do. Ask sir, that did it do? And let me tell you yes or no. So you did very well. Proud of you. I know some of you who would have done Cape Math before, this is just like a revision for you. But there are areas that are coming that you were not introduced to in Cape Math, those Cape Math students, so don't take it for granted. There are areas that you have not done. There are areas that you will be doing in Unit 2 that we're going to be talking about. So catch it now. So when you catch Mr. Rookwood, you can say, sir, QED, quite easily done, and just show him so you know the stuff, all right? So thank you for coming out. I see you on Monday, all being well. Sleep tight, enjoy your weekend, and continue to be safe.
Same to you, sir.
Bye, sir.
Bye,
Thank
sir.
you.
Bye,
To
sir.
send this to the
Bye,
group, right?
sir.
I'm going to send it to the group right now. Yes. Bye-bye, hon.
Bye,
Bye,
sir.
sir.
Bye-bye, dearest. Take care.